The goal for this video is to know and understand an alternative form to find the turning point for a quadratic. So we'll call this an alternative form on top of what you already know, and we can see that we've got our polynomial form for a quadratic there, and what we can do is take a factor of a out and we get this resulting line here. What we're doing on the next line might take a little bit more time to digest. That's completing the square. So what we have with a factor of a already removed, we've got to complete the squared term, and probably need to dissect this one a little bit more. Most easily, the c over a is that c over a there. We've got the first term here, we've got the second term needing more explanation. So let's write this form out in a different way. We normally use a, b, or x and y. It's a bit confusing because those letters are already taken up in this situation here. So let's call it p plus q all squared. Okay, it's still a perfect square, so it's p squared plus 2pq plus q squared. Alright, that's our perfect square format. And what we do have is that p squared is equivalent to what we have on the left there, x squared, and 2pq would be the same as b over a. Now, because p is equivalent to x, b over ax, we can just remove those from consideration. So 2q equals b over a. So q by itself is b over 2a. Okay, so that's how you halve it, you double the denominator. So q squared, of course, would be b squared over 4a squared. So if we go back, we can see that's where the b squared over 4a squared comes from there. But of course, that's what we've added on, so we've also got to take that off as well. The perfect square is made up of these parts here. So those bits get bracketed off, and the rest of it sits outside. Recalling our turning point form, okay, we've got y equals a outside of x minus h all squared plus k. So you can see some parallels there. The h for the turning point would be this bit here. So to get it a plus, it must be negative b on 2a. So the x coordinate of the turning point is what h is from our previous work. So to get the turning point, basically to get the turning point, we have to go, the x coordinate of the turning point equals negative b over 2a. So that's important to note right there. So for the turning point, we've got negative b over 2a. That's the x coordinate of a turning point. So how do we get the y coordinate? Well, like anything, if we know the x, we can substitute it in to the function, and the y coordinate of the turning point would be, if you subbed negative b over 2a into the function, that would be f of negative b over 2a will give you the y coordinate of the turning point. So both of those together will give you the x and the y coordinates of the turning point. To clarify, let's look at an example. Okay, it's a, b, c. So a equals 3, b equals negative 6, c equals negative 4, and to get the turning point, we need the x value, which is negative b over 2a, which is negative of negative 6 over 2 times 3. Negative negative 6 is positive 6, positive 6 over 6 is 1. And the y value of the turning point, you substitute, it's f of 1. So we substitute 1 into the function. It's just function notation in action, isn't it? Minus 6 by 1 minus 4 equals 3 minus 6 minus 4, which is negative 3, minus 4 is negative 7. So the turning point in total is 1, 7.